I want to look at this example that says to show that the limit as x approaches 0 of x to the fourth cosine of 2 over x equals 0. And if I use my standard limit laws, this is actually a difficult problem. But if I make use of the Squeeze theorem, it actually becomes pretty easy. So the Squeeze theorem says that if g of x is some function that's trapped in between f of x and h of x at a point A or near A, and the limit as x approaches a of f of x equals L, which is the same as the limit as x approaches a of h of x, then the limit as x approaches a of g of x is L as well. And what this is saying is, if I have a graph, so let me make a graph, and let's specify point A, and the f function goes something like this. So it crosses A right here. Maybe it trends towards A around that. So this is my f. And my h of x is something on top, but it trends towards that same value at A. Okay, this is L right here. Then the guy that's trapped in the middle, which is my G, the guy who's trapped in the middle, G, when it gets close to A, it has no choice but to pass through that same value of L. Okay, now how is that useful here? Because I know something. What I know that cosine of 2 over x is trapped between the value -1 and 1. How do I know that? Because if you look at the graph of cosine, it goes between 1 and -1. And it just kind of oscillates back and forth for any value of x. Okay, so cosine of 2 over x is trapped between -1 and 1. So what I can do then is multiply everything by this x to the fourth. So I get negative x to the fourth is less than or equal to x to the fourth cosine of 2 over x, which is less than or equal to x over the fourth. And I also know that when I take the limit as x approaches 0 of negative x to the fourth, I get, well, that's a polynomial, so I can just plug it in. I get 0, which is the same as the limit as x approaches 0 of positive x to the fourth. Okay, so the two endpoints, the two outside portions of this inequality, both trend towards 0 at 0. So that means this guy, by the Squeeze theorem, I know that the limit as x approaches 0 of x to the fourth cosine of 2 over x has to equal 0 as well. Okay, I hope that makes sense. Again, the idea is I've trapped my function. It looks something kind of like this, actually. So at 0, here I have positive x to the fourth, which is something kind of like that. And negative x to the fourth, something kind of like this. And that value in the middle does some sort of oscillation, kind of like this. And so it has no point, it has no chance but to go through 0 right at x equals 0. So this is x to the fourth cosine of 2 over x. Okay, I hope that makes sense. If you have any questions on this, let me know. I'd be glad to help. And thanks for watching.